In today's lecture, I will discuss about the tolerance test, and this video lecture will be a complete package for tolerance test. I will also discuss the miscellaneous example related to the tolerance test, or I also I also discuss here a JEE advanced question. Okay, let's start. First, what is the meaning of tolerance test? There is a silver, okay, which is in positive plus one oxidation state, and after reacting it convert into Ag elemental silver, and which gives us a silver layer. Okay, so from here we got a concept, that is, if there is after a reaction there is a formation of silver layer, that's mean it gives us a positive tolerance test. Okay, now let's see first the preparation of tolerance reagent, that is, we have to use silver nitrate. Okay, we have to use silver nitrate with sodium hydroxide and gives us Ag2O brown PPT. Okay, plus NaNO3 sodium nitrate plus H2O. Okay, and now this brown PPT Ag2O will react with ammonia and sodium nitrate NaNO3 plus water and gives us 2Az NH3 whole twice and NO3. Okay, plus 2 NaOH. Now here you can say Az are in 2Az are in plus 1 oxidation state. Okay, now we can say it will act as a oxidizing agent. Why? Az positive will fastly convert into elemental, which is zero oxidation state, to gain stability. So that's why we can say it will act as oxidizing agent. Self it will be reduced and oxidize the another species. Okay, oxidizing agent. Now let's see the mechanism and which species will give positive tolerance test. Okay, first we will take aldehyde. Okay, let me write first a normal reaction. ROH aldehyde react with Az NH3 whole twice plus 1 charge, and again we can write 3OH negative, and we get here elemental silver. That silver is in zero oxidation state, or it form silver layer, metal silver layer, or we can, that's why we already tells the tolerance test by silver mirror test. Okay, now let's see the mechanism. Here we use Az positive, we add the tolerance reagent in the solution, and Az positive gain electron after homolytic cleavage of carbonyl. Here you can see there is a homolytic cleavage. Okay, now this Ag positive take this electron and convert it into elemental silver and gives a species which have positive charge on carbon, and here is nitrogen. And now this reaction already occur in basic medium, so we can say this OH negative will attack on this positive charge and gives us a species, that is R, OH, O radical, and H. Now this radical, this hydrogen will can show, it can show homolytic cleavage. Okay, there will be a homolytic cleavage, that is R, OH, O radical, here is also radical, and H radical. Now this H radical will make a bond with oxygen, that is radical coupling, and gives us a species, that is R, OH, and again radical on carbon. So now as we know this reaction occur in basic medium, so again this OH negative take this hydrogen and gives a R, O negative, OH, and this radical, and again there is 2 mole of Ag positive. So again this Ag positive take this electron, take this electron, a single electron, and convert it into Ag0 and we get here O negative and positive, okay, and OH. So we can see here minus and plus in neighboring atoms, so it can be converted into double bond, that is donation to electron deficient site, and we got here RCOH, or we can say here uh, as the reaction occur in basic medium, so this is highly acidic hydrogen, so it can convert into carboxylate anion, okay. So from here you can see there is a 2 mole of Ag positive converted into Ag0, and now this Ag0 will show us a silver layer, okay. So from there we get the information that this aldehyde give positive tolerance test, and this mechanism is known by single electron transfer, because there is a single electron transfer to the Ag positive and converted into Ag0. So this is mechanism followed single electron transfer, okay. Now let's see further some miscellaneous example, that is alpha hydroxy ketone OH, okay, and this is at alpha, so I said alpha hydroxy ketone, okay. Now OH negative in equilibrium, it is in this state, as and you can see now here again it is a aldehyde, so we can say alpha hydroxy ketone also give positive tolerance test, okay. Let's see more example, okay, that is hydrazine. Here you have maybe you have some misinformation about the tolerance test, that you can think like only aldehyde or alpha hydroxy ketone give the positive tolerance test, but it is not true. Hydrazine also gives positive tolerance test. Let's see how. Now when hydrazine react with again 2 moles of Ag positive, it gives a reaction N2 plus 2Ag plus 4NH2 plus 2H2. N2 why? Because you can see already know N2 is a gas, so it is a driving force for this reaction, so and now you can see Ag converted into 0 oxygen, Ag0, that is elemental form, so silver layer will be formed. So we can say it can show positive tolerance test because it reduce the Ag positive. Any species which can reduce Ag positive to Ag0 will give positive tolerance test, okay. Now the another example, ammonium hydroxide. When it react, it gives nitrogen monoxide gas plus 2Ag plus 4NH3 plus 2H2O. Here you can again see Ag is in elemental state, so we can say again it will form a silver layer and give this, both species gives positive tolerance test, okay. Now come to the new word, that is hemiacetal. What is the meaning of hemiacetal? Like here you see the example, but in biomolecules, monosaccharide, disaccharide, polysaccharide, you have to know, to get the information about the positive tolerance test they give or not, we have to first know hemiacetal. What is the meaning of hemiacetal? That is, if there is a carbon which have ether attached and one side have OH, that species will be known by hemiacetal, okay. So if there is a hemiacetal group present in any species, then that species will give positive tolerance test, okay. Let's see here some example. I take glucose. Here it is easy because aldehyde group present, so we can say it can give positive tolerance test. But in cyclic form, here is no aldehyde or ketone, so how you can see? That is, here is a carbon which have hydroxy group and one is ether, so we can say it can show it is hemiacetal, so we can say it can show positive tolerance test, okay. Now let's take an example of fructose, that is a alpha hydroxyketone, so it can also give positive tolerance test. Okay, it can also give positive tolerance test. Now some more example, that is lactose. Lactose have also, you can see here, one hydroxy and one is ether, so it have also hemiacetal group. And maltose also have hemiacetal, one hydroxy and ether, so we can say these maltose and lactose also show positive tolerance test. Okay, now there is some question which I took here from JEE advanced question paper, that is benzoin, and further we can see here after preparation benzil. Okay, this both species also give positive tolerance test. Let's see how. pH, when it react with in basic medium in basic medium, it can convert into RO negative O, here pH, and we can see here it can show tautomerism. Oh, it now here is a highly acidic hydrogen which can be gives us a water. Okay, so this species will convert into okay. Now here will be a single electron transfer. Let's see how. Again, Ag positive. We have to see Ag positive reduction. Is it, if it is possible, that means this species can give positive tolerance test. Okay, Ag positive. Okay, now this positive take this electron from one electron from this oxygen and convert into Ag0 and gives us O negative, O radical, and pH. Here you can see it can show resonance, or we can say radical, again homolytic cleavage like this, and we can get this same species. And again, if there is another mole of Ag positive, it can also take this electron from oxygen and convert into Ag0 and gives us pH, O radical, and pH. Okay, now you can see here, if there is a homolytic cleavage in this bond, then here is radical coupling, and we get the species benzene. Okay, now after benzene formation, so from here we reach the species that is benzene. Now if again we attacked with OH negative, here you will see here is a carbonyl center that is electron deficient, so OH and pH. Now again it can attack and there will be a rearrangement, phenyl will be shifted to this carbon. Okay, let's see how. pH, and again when this phenyl attached to this carbon, then again this double bond will break and here the oxygen will get negative charge, and here pH, O and OH. Okay, again we know here this carboxylic group have highly acidic hydrogen, so it can transfer to this negative charge oxygen, so it will convert into OH, again pH and O negative. Now here you can see here is a driving force of this reaction, that is elimination of carbon dioxide. Okay, release of carbon dioxide. Here it will attack at this bond and carbon dioxide will be released and we will get ROH, carboanion, and pH. Again Ag positive take this electron, single electron, and convert into elemental state and gives ROH, pH and positive charge, and again you can see here electron deficient site, so it will be converted into this. Okay, you can see here again Ag positive convert into elemental form, so we can say it will give benzyl, and benzoin will give positive tolerance test. Okay, positive tolerance test. And this mechanism you can see in mark advanced organic book. Okay, for more clearance you can see the mechanism of this question. Okay, now let me conclude. Tolerance test given by aldehyde, formaldehyde, okay, ammonium hydroxide, N2H4, alpha hydroxyketone. Oh, alpha hydroxyketone, or here is ester. Okay, alpha hydroxy. Here is benzoin, benzyl, and another example maltose, lactose, fructose, glucose. All these species will give positive tolerance test. Now, last, okay, I will discuss in. So let me show. Uh, these species which give positive tolerance test are known by reducing sugar. Okay, and which species which not give tolerance test, which not give tolerance test, that species will be known by non-reducing sugar. Okay, and here is the example, that is sucrose. Okay, sucrose not give positive tolerance test because here is no hemiacetal group present on this species. Let me show you fastly. Now this is the structure of sucrose. Okay, sorry, here is 5 carbon cyclic chain. Okay, cyclic. Okay, here again CH2OH, OH, and where I did not attach the hydroxy, that means here is hydrogen. Okay, here is hydrogen. So here you can see there is no hemiacetal group which have attached direct OH and ester, sorry, ether. Okay, so we can say sucrose not give positive tolerance test and it is non-reducing sugar. So from here you can see which species can give this species. If this species, sorry, if the species can give positive tolerance test, that means it is reducing sugar. Okay, so this is the complete information about tolerance test, and now there will be no more confusion about this topic. Okay, thank you. And if you like this video, please subscribe to IITN YouTube channel. Okay, thank you.